You can annotate on the screen. You can also use your mic or a chat to answer the questions. We have aqueous ammonium sulfate is warmed with aqueous sodium hydroxide. The pungent gas ammonia is given off, it is produced. The balance equation for this reaction is shown. Balance equation for this reaction. You can annotate on the screen to balance. We have 2 sodium. Okay, sodium is balanced. Nitrogen, this 2 is multiplied here. This 2 nitrogen is balanced. Sulfur is 1, it's balanced. What about hydrogen? We have 4 multiplied by 2, 8, and plus 2, 10 are there. Because if you see this number, 4 multiplied by 2, here we have 8. And this 2, if you write this 2, so it makes 10 total. So we need 10. So 2 multiplied by 3, that makes 6. What should be the number here? So it should, no, we already, this is the reactant side. So this 2 is multiplied. So this makes 2 hydrogen, and 4 multiplied by 2 makes 8 hydrogen. So what is the total sum? 8 plus 2 makes 10. We want to make 10. 2 multiplied by 3 makes 6. So what should be the number here? It cannot be 5, because if I write 5, 5 multiplied by 2, 10 plus 6 makes 16. So that won't be correct. So what should be the number here? It should be 2, because 2 multiplied by 2 makes 4, and 6 plus 4 makes 10. And you can check the oxygen should also be balanced. So how oxygen is balanced? You have 4 plus 2, 6, because there's 4 and 2. So you have 2 here and you have 4 here. So oxygen is also balanced. So this is a balance equation. So it is, you just have to write 2 here, 2 here, and 2 here. The next question, 2.8 grams of impure ammonium sulfate is found to contain 0.7 grams of impurity. What is the percentage of ammonium sulfate in the sample? So if we have 0.7 gram is impure, out of 2.8, 0.7 is impurity, how much ammonium sulfate will be there? Because percentage of ammonium sulfate will be, the percentage of ammonium sulfate, mass of ammonium sulfate in the compound. So this will be 2.8 is a total impure sample which contain 0.7 impurity. So 2.8 minus 0.7. So it will be 2.1 divided by the total mass of the sample, which is 2.8, and multiplied by 100. So this will give us the percentage of ammonium sulfate in the sample. Describe a test for the ammonia gas. So how we can test? We can use a dim red litmus, and that red litmus will turn blue. That will be the result whenever ammonia gas is there. Ammonia gas is prepared at the front of a lab. The pungent smell of ammonia spread throughout the lab slowly. Name the process that occur when ammonia gas spread out. So we call that as a diffusion. Because of the diffusion, the gas spread out. Explain using the idea about the particles why ammonia gas spread out throughout the lab. So first thing, because it's a gas, how the particles are moving? The particles are moving randomly. And as they are moving randomly, they collide with each other and they changes the direction and spread out. So the gas random motion is there, continuous collision. Gases are moving randomly at high speeds, the particles in the gas. So as a result, if we have these particles, they're moving randomly, high speed, colliding, changing direction. That's why the gas diffuse much faster than a liquid. The next is explain why carbon dioxide gas CO2 will spread through the lab at a slower rate than ammonia. So when you work out because the diffusion depends on the mass. So carbon dioxide, carbon is 12 and oxygen is 16 multiplied by 2. So total mass is 44. But when you check ammonia, it is nitrogen is 14 and hydrogen is 3 makes 17. So as you can see, ammonia is lighter. So CO2 is having a higher mass or greater mass or greater molecular mass. Relative molecular mass is a best term in terms of, because it's not only the mass, it's the relative molecular mass, which is compared with the 12th part of a carbon. So when you mention a mass, atomic or a molecular mass, better use the term relative atomic mass or relative molecular mass. The next is ammonia is produced in the Haber's process. The equation for a Haber process is shown. In the Haber process, the temperature is 450 and the pressure is 200 atmospheres. A large equilibrium yield, like we get more product if a temperature is lower and a pressure is high. Suggests why a low temperature and a high pressure is not used. Why we did not use a very low temperature? Because the rate of a reaction would be very slow. And why high pressure? High pressure is like, you can mention about high pressure, it will be not economical or it will be expensive. You can mention here. And about the temperature, low temperature, if it low temperature is economical, so you cannot mention economics about the temperature. You should refer high pressure, it will increase the cost, and low temperature will reduce the speed or the rate at which the reaction happen or occur. The danger of a high pressure, not really is the part. No need to mention about the danger. It's in terms of cost. The best thing is mention in terms of the cost. State the role of the high iron in the Haber's process. So iron is used as a catalyst. Ammonia is a weak base. What is the meaning of a term base? So whenever acid and base, that's right, you will always mention bases are proton acceptors, and suggest the pH of aqueous ammonia. It's a weak base. So what will the range of the, in exam, you're not supposed to write the range, write the number. So any number acceptable, like 8 to 11, any number you can write, 9, 10, 8, fine. These all are correct. So term base, it's a proton acceptor, or look, base is having different definition, or it is OH ion donor. If you write base is a OH ion or hydroxide donor, but this definition is not valid on all the condition. Like example, when I say ammonia, example, when I say NH3, NH3 cannot donate OH. So I cannot apply that definition of the OH ion donor. In that case, like if it is reacting with HCl, it will form ammonium ion plus chloride ion. So the standard definition of a base is a proton acceptor. Even though base can donate hydroxide ion, but the standard definition for a base is a proton acceptor, and acids are proton donors. Metal oxide, metal hydroxides are also known as the base. 7 to 12 was given as a range, like above 7. This question is about the reactions of base and acids. Ammonia is a gas at room temperature. What is the test for ammonia? And describe the positive result. How we can test that there's ammonia gas? Damp. Don't forget to mention the damp, because the damp condition, as the damp litmus is there, it can be absorbed, the ammonia gas. So it should be damp. Damp red litmus, and that's right, it will turn blue. In part B, ammonia react with water to form the ions, as you can see here. How does this equation show ammonia behave as a base? Again, the same question. So because it has accepted proton, you can see NH3 become NH4. So if NH3 become NH4, it has accepted proton or it is taking proton. Suggest the pH of a weak base. Again, a similar question about the weak base. Then describe what is seen when aqueous ammonia is added to a copper 2 sulfate until no further change. So first, when we add aqueous ammonia means ammonia solution is added. This is also a test for positive ion. Aqueous ammonia can be used to test the positive ion like iron 2, iron 3, copper. So initially when we add, so it will form a, no, precipitate. This is aqueous ammonia. So aqueous ammonia precipitate, this is not correct. Aqueous ammonia, the precipitate dissolve and it will form a deep blue or inky blue or royal blue solution. So blue precipitate is correct. When in excess, what will happen when we add excess of aqueous ammonia? As a result, the blue PPT, the blue precipitate will dissolve. And when this blue, it will form a royal blue or an inky blue solution or dark blue solution. So with aqueous ammonia, it is dissolved. In part C, aqueous sodium hydroxide is a strong alkali that react with dilute sulfuric acid exothermically. What type of reaction is this? When sodium hydroxide is reacting with sulfuric acid, what we call neutralization. Good. Then when sodium hydroxide is reacting with sulfuric acid, so when a metal react with acid, so it will form a sodium sulfate. The formula for sodium sulfate, sodium is +1 and sulfate is -2. So sodium sulfate will be Na2SO4 and plus H2O will be there. So salt and the equation must be balanced. You have to balance the equation. Look, when 2 marks are there, you have to complete and balance this equation. So how to balance? Because 2 hydrogen here and 2 hydrogen. So we want 4 hydrogen. So we put 2. So the equation will be balanced. So it's not only H2O, it should be 2 H2O. So it will be Na2SO4 plus 2 water molecules for a balanced equation. 1 mark is for completing a product, 1 mark is for the correct balancing. The next question is, a student wanted to find the concentration. We have to use that equation as well. Student wanted to find the concentration of some dilute sulfuric acid by titration. The student found that the 25 cm cube of 0.04 dm cube exactly reacted. Name a suitable indicator. So methyl orange, phenolphthalein, methyl orange, screen methyl orange, thymol, pethylene, different indicators you can mention. Calculate the concentration of a sulfuric acid using the following steps. Calculate the number of moles of sodium hydroxide in 25 cm cube. So we have 25 cm cube and the concentration is 0.04. So moles equal concentration times volume. The concentration is 0.04 and the volume is 25 cm cube, but we have to convert into decimeter cube. So we divide it by 1000. So this will give us 0.001, I guess. Yeah, 0.001 mole will be there. Now, deduce the number of moles of sulfuric acid. So how to deduce the number of moles of sulfuric acid? The first one, we use a formula. So the second part, we'll use a ratio. And what is the ratio between the sodium hydroxide and sulfuric acid? The ratio is 2:1. So if we have sodium hydroxide and we need sulfuric acid, 2 moles of sodium hydroxide react with 1 mole of a sulfuric acid. So if you have 0.001, how many moles will be there? X. We cross multiply. So it will be half of it. So 0.0005 moles will be there, which is 5 exponent minus 4. You can write your answer in decimals. You can also write your answer in exponents. So we got the moles 0.0005 and we have the volume of a sulfuric acid 20. So the last part we need the concentration. So how we can work out the concentration? Concentration is moles divided by volume. So moles were 0.0005 and the volume was 20 cm cube. So we divided by 1000, 0.02. So 0.0005 divided by 0.02. So 0.025 moles per decimeter cube. That's a concentration. Then calculate the concentration of sodium hydrox 0.05 mole per dm cube in gram. So if you want to convert the concentration from moles to grams, we multiply by the molar mass. So the concentration is 0.04. And what about the molar mass of a sodium hydroxide? Because we need for sodium hydroxide. So sodium, you will use a periodic table. Sodium is 23 plus oxygen is 16 plus hydrogen is 1. So this will be 40. So 0.04 multiplied by 40. So that will be 1.6 grams per decimeter cube.